Question number 5. This question is from forces and equilibrium. Four coplanar forces act at a point. These are the four forces: 10 Newton, F Newton, 50 Newton, and 40 Newton. The magnitudes of the forces are F Newton, 10 Newton, 50 Newton, and 40 Newton. The directions of the forces are shown in the diagram. These are the directions of the forces. Given that the forces are in equilibrium, find the value of F and the value of theta. First, we resolve these forces and will find F Newton force will be resolved and 40 Newton force will be resolved. 10 Newton force will not be resolved because only one component along x-axis and this force 50 Newton. Its x component is 0. This is y component, and we will resolve these F Newton and 40 Newton forces and find two rectangular components of each. Given the forces are in equilibrium. For equilibrium, this is a condition for equilibrium. Sum of forces along x-axis 0 and sum of the forces along y-axis 0. These are the conditions for equilibrium. First, we make the diagram again. 10 Newton force and this is 50 Newton force. Angle is 90. This force is F Newton. This force is 40 Newton. This angle is theta. This angle is 60 degree. Now first we resolve F Newton force and find two components, rectangular components. X component and this is the Y component. This component is F sin theta. This component is F cos theta. The component against theta will be in sine. So this is F sin theta, this is F cos theta. Now in the same way we will resolve 40 Newton force. This component is X component, Y component. Now this component opposite to the angle will be in sine. So this will be uh, 40 sine 60. This component is 40 cos 60 degree. And now we have to find, given that the forces are in equilibrium, find the value of F and the value of theta. So these are the conditions for equilibrium. For equilibrium, sum of forces along x-axis is 0, and sum of forces along y-axis 0. So forces along x direction 10 plus f cos theta and minus 40 cos 60 degree, because the direction of this component is in opposite direction of 10 Newton force and f cos theta. So we will write f cos theta, f cos theta plus 10 minus 40 cos 60 degree, f cos theta plus 10 minus 40 cos 60 degree is equal to 0. This is sum of the forces along x-axis 0. In the same way, sum of the forces along y-axis, this force plus this force minus 50 is equal to 0. So f sin theta plus 40 sin 60 degree minus 50 degree minus 50 Newton is equal to 0. Now we will simplify these two equations using the values of cos 60 degree, sin 60 degree. We get this equation becomes f cos theta minus 10 is equal to 0, and this equation becomes f sin theta minus 15.359 is equal to 0. Let this is equation 1 for reference. This is equation number 2. Now we will solve these two equations simultaneously to find the value of f and theta. Now from this equation 1, we can write f cos theta is equal to 10. From equation 2, f sin theta is equal to f sin theta is equal to 15.359. Now we will divide these two equations. In this way, f will be cancelled out. So we can write f sin theta over f cos theta is equal to 15.359 over 10, cancel out, f is cancel out. We get sine over cos, that becomes tan. So tan theta is equal to 1.5359. From here, theta will be equal to tan inverse 1.5359. We get theta is equal to 56 point, 56.932, 56.932 degree. But we will write theta in correct one decimal place. So answer is theta will be 56.9 degree. correct to one decimal place. Now we will put this value of theta in the in any equation. We are putting this value of theta, not rounded figure, but yeah, three decimal places. The value of we will take this value of theta in three decimal places, putting in equation one. We get equation putting the value of theta in equation number one. We get f cos theta is equal to 10. From here, f is equal to 10 over cos theta. Value of theta is 56.932 degree. We are using this. We will not use this rounded figure. We will use this value of theta here to write the answer in correct accuracy. So after calculating, we get the value of f is equal to 18.3 Newton. This is the answer and three significant figures. 18.3 Newton, value of f and value of theta is 56.9 degree. Now part B of this question is given instead that f is equal to 10 under root 2 and theta is equal to 45. Find the direction, find the direction and the exact magnitude of the resultant force. So this is formula to find a resultant. Magnitude of the resultant will be sum of uh, square of the sum of x forces plus sum of y square whole under root. This is the magnitude of the resultant and the direction of the resultant will be tan inverse summation y over summation x. We will use these two formulae to find the exact magnitude and direction of the resultant. Now, summation x will be now the value in this part, the value of f and theta are given. We are using these formulae. First of all, we will find sum of the forces along x-axis, that is summation x f cos theta. Already we have found f cos theta plus 10 minus 40 cos 60 degrees. Now the value we will put the value of f and cos theta and the value of theta, that is 45. The value of f is 10 under root 3. And summation x will be 10 under root 2 cos 45 45 degree plus 10 minus 40 cos 60 degrees. After calculating, we get the value of summation x will be 0. By using calculator, we get the value of summation of x is equal to 0. In the same way, we will find summation y. Already we have found in part 1, part A, f summation y is equal to f sine theta plus 40 sine 60 degree minus 50, putting the value of f and theta here, we get summation y is equal to 10 under root 2 sine 45 degree plus 40 sine 60 degree minus 50. We get summation y is equal to, we are using here a calculator. We get sigma y is equal to, we will take the values of summation y and summation x in exact form, not in decimal places. We will take these values in exact form. So we get minus 40 plus 20 under root 3. Now this is summation x is equal to 0, summation y is equal to minus 40 plus 20 under root 3. Now we will find the value of magnitude of the resultant. Magnitude of the resultant, magnitude of the resultant force, that is, this is the formula summation x square plus summation y square whole under root, putting the values, we get r will be 0 plus minus 40 plus 20 under root 3 whole square whole under root. Uh, Now if we calculate this minus 40 plus 20 under root 3, we get this value. If we are taking square root, this square is cancelled out with this square root, we get r, the value of r is, r will be minus 40 plus 20 under root 3. But if we calculate that, we get this value minus 40 plus 20 under root 3. If we check this figure in decimal places, we get value negative, but r is never be negative because we have to find the magnitude of the resultant. So here we can write this minus 40 plus 20 under root 3. We can write it, it is also equal to, because it is whole square of this. So to avoid from the negative sign, we can write it r is equal to 40 minus 20 under root 3 square whole under root. We can write, no, square is cancelled out with square root, so we get r is equal to 40 minus 20 under root 3. This is the answer. This is the magnitude of the resultant force. Now we will find the direction. Direction of the resultant will be, direction of resultant force, uh, theta is equal to tan inverse summation y over summation x. Putting the values of summation x and summation y, we get summation y is minus 40 plus 20 under root 3 tan inverse minus 40 plus 20 under root 3 divided by summation x is 0, because we have already found, and this value is, y component is negative, but X component is 0. Negative 1 negative Y component and X component is 0. This means that uh, X is 0 and Y component is negative, Y component negative, X component is 0. So this means that the direction of the resultant will be along the force, this force, 50 Newton force. So direction, it is very clear that for this 50 Newton force, X is 0. If we are taking this force as X-axis, along x-axis. If we are taking this along this force of 10 Newton along x-axis, and this must be along y-axis because angle between these forces is 90. So along 50 Newton force, x is 0, y is negative because it lies in the negative uh, y-axis. So direction of the resultant will be mm, in the same direction as 50 Newton force. So we can write that direction of resultant is in the same direction as 50 Newton force.